What if you could hear the Ice Age? Not read about it, not look at a graph, actually sit in a room and listen to 110,000 years of Earth's climate history unfold, every ice age, every volcanic eruption, every shift of the ocean's currents as music. That's exactly what one scientist and musician set out to do. And what he created is one of the most mind-bending things I have ever come across in all my years of falling in love with snow, ice, and nature. Hi, I'm Danielle, snowflake preservation artist, Colorado. Today we are talking about the Climate Symphony. Let's start with the ice. In 1989, a massive international drilling project began at Summit, Greenland, the highest point of the Greenland ice sheet. Over the next 5 years, scientists drilled down through nearly 2 miles of ice, all the way to the bedrock, extracting a continuous column of ice called the GISP2, the Greenland Ice Sheet Project 2. Think about that. Every layer of that ice is a year. A snowflake falls, gets buried, gets compressed, and locked inside it are microscopic traces of whatever was in the atmosphere when it fell. Dust from distant storms, salt from ocean waves, sulfur from volcanic eruptions. Way around the world, the chemical fingerprint of an entire year. Frozen in place, stacked on top of every year before it. When scientists analyzed the chemistry of that 2-mile core, they had access to 110,000 years of climate history. Temperature swings, ice sheet advances and retreats, solar cycles, ocean circulation shifts, the rise and fall of ancient atmospheric chemistry. All of it preserved in layers of ice. And what did it look like when they put that data on a page? Squiggly line. It's actually what Marty Quinn described it as when he first saw the data. Quinn is a professional musician and researcher, a drummer, composer, and data scientist. And he'd been invited to a presentation by Dr. Paul Mawitzki, the director of the Climate Change Research Center at the University of New Hampshire and the lead scientist behind the GISP2 project. He is the kind of scientist people call the Iceman. He had spent his career drilling into glaciers and reading the story the ice tells, and Quinn sat there looking at all these graphs and all these data files representing all these years of Earth's climate, and he said, I felt like it should be more. It should be experienced, like it should be music. So he built a piece of software called Design Rhythmics and spent years figuring out how to translate that data into sound. And the rules he came up with are fascinating. Here's how it works. The GISP2 data contains 10 different climate variables. Things like ocean circulation patterns, solar variability, ice sheet movement, volcanic activity. Each one has its own cycle, its own rhythm, and its own personality. Quinn assigned each one a different instrument. Volcanic eruptions got the drums. The louder the cymbal, the bigger the eruption. Solar intensity cycles play on a vibraphone, bright and warm with higher melodies when the sun burns hotter and lower melodies when it cools. Ice sheet movement became percussion. When the ice sheets were expanding and the world is cold, you hear cowbells. And when the ice retreats and things warm up, it shifts into tom-toms. Earth's wobble on its axis. The Milankovitch cycle that makes some summers hotter than others plays as a pipe organ. Low notes for minimal tilt, high notes for maximum. And underneath all of it, a single string section moves slowly, steadily from the lowest note to the highest note over the entire 7 minutes of the piece, representing time itself. 110,000 years in 7 minutes. That's about 260 years per second. The first time Quinn played it at the University of New Hampshire in 1995 at a science honors dinner, the audience heard something that no human had ever heard before. It was the sound of the Ice Age. The sudden deep freeze that hit Earth about 4,000 years ago shows up as a jarring downward shift in pitch. The temperature plummeting and instruments dropping, and then it's just suddenly warming again and you can hear it. Not interpretation from a chart, hear it. The Climate Symphony has since been performed at the American Museum of Natural History at MIT Lincoln Lab and at the National Science Foundation. It runs just over 7 minutes. It feels like it compresses more history than you can hold in your mind, something your body can feel, and Marty Quinn wasn't alone in his idea, because once one person does something, it turns out others had been circling the same thought. Judy Twitt, an atmospheric scientist at the University of Washington, took decades of Arctic sea ice data and translated it into a piece for piano. As the years progress and sea ice shrinks, the notes fall lower and lower on the keyboard. By the second half of the piece, the pianist's right hand has to physically cross over the left to reach the lower notes because the ice is constantly below the long-term average. It's not just heard, it's seen in the body of the musician. The disappearance of ice becomes a gesture. In 2024, a Japanese geoenvironmental scientist named Hiroto Nagai published a peer-reviewed study in the journal Science about a 6-minute chamber music composition he created from 30 years of polar climate data from the Arctic and Antarctica. Solar radiation, temperature, precipitation, cloud thickness performed by a string quarter. Participants who heard it reported feeling a new emotional urgency about climate change that graphs and data had never given them. And this is the point that all of these scientists and artists keep coming back to. Data is accurate, but data feels distant. You can look at a graph that shows the planet warming and file it away in the part of your brain that processes abstract information. But when you hear it, when a crash symbol hits and you feel it in your chest, that a volcano just erupted and caused global cooling, something different happens to your body. Somewhere that a number doesn't think about what I do. When someone sees a snowflake in person, really sees one through a lens in all its impossible geometry, it stops being frozen water and becomes something you can't look away from. The science doesn't change, but the experience of it does. And that's what I'm trying to give people when I preserve a snowflake, a moment where the wonder hits before the explanation does. That's what Marty Quinn did with 110,000 years of ice. He didn't simplify it, he didn't make it easier to understand, he made it impossible not to feel. And somewhere in a research lab, a 2-mile column of Greenland ice is still holding all those years. Every volcanic eruption, every ice age, every slow wobble of the Earth's orbit, waiting to tell its story to anyone who knows how to listen. I'm Danielle Oliver. I preserve real snowflakes out here in Penrose, Colorado. You can find my work at PreservedSnowflakeCO or on Etsy at PreservedSnowflakeCO. See you in the next one.